This is UniTalk, the podcast series of the University of Debrecen. We've saved you a seat. In each episode, we'll show you a different aspect of life at UD. Students, professors, and researchers will take you behind the scenes to talk about their life, work, and passion.
Hello, everybody. This is UniTalk, the new podcast series of the University of Debrecen. Today, I'm here with one of my colleagues, Esther,
Hi.
and I'm Dori.
Hello, everyone. Today we have József Baranyi with us, who is the scientific advisor of the Institute of Nutrition of the University of Debrecen. He's also a mathematician. Hello, József. How are you today?
Fine, thanks.
Could you please tell us a bit about yourself?
Well, as you said, I am a mathematician. My name is József Baranyi, and I graduated in Szeged as a mathematician. Then I worked in Kecskemét for 9 years, and then I spent altogether 28 years in England in Norwich Institute of Food Research, where they just called me József or Joseph sometimes, which I'd never liked. So I said that either József or Joseph. So you are welcome to call me either Joseph or József, but never say Joseph.
Okay.
Duly noted. Seeing you have a very impressive professional background, what would you say are the highlights of your career so far? If you could explain a bit about that.
Well, I am old enough to give a list of these, unfortunately, but mainly I started this in the Kecskemét Technical College, where I think the best time there was dealing with students. So I was very proud that the students chose me not even once, as far as I remember, the teacher of the year. And that made me like the young people, how to grow them real scientists. And then I got a job first, a studentship, as a postdoc in Uppsala, in Sweden, from where I went to England. And in 1990, I started to work as a biomathematician in the Institute of Food Research in the microbiology department. We worked on bacterial processes, mathematical modeling. We predicted all sorts of things with the bacteria. And in the from 2000, I got my own research group. It was called Computational Microbiology Research Group, and we had lab. All along I worked with microbiologists until 2016, where I became 60, so I retired in England, and then the university asked me to be a scientific advisor, so I am here from 2017 in Debrecen.
Your field of expertise seems to bridge multiple academic fields. How do you put this interdisciplinary approach to use at the university as a scientific advisor?
Well, that was exactly the point. I frequently call this bridge building, as I became bridge builder in many sense, not only scientifically, but also culturally. So imagine when I arrived in Sweden, that was 87 first time, and then coming from a communist country to the West. At that time we had this big thing, and then in 1990 starting in a government-based institute in England, where half a year was needed just to check if I am a KGB agent or not. So coming from a different culture, arriving, that is a bridge building, culturally bridge building, but also scientifically bridge building mathematics and microbiology. And I continue this here as well. So my main job at the Institute of Nutrition is to try nutrition a more exact science. This is what many people consider the measure of exactness of a science, how much it is able to use mathematical techniques, mathematical models. That's what I try to put in practice in nutrition, which is currently very fuzzy, some sort of science, because a lot of subjective, not defined concepts are around nutrition. And with my collaborators, primarily, I have to mention Barabashi Albert Laszlo, an old friend of mine, whom we started to think about this. Laszlo, you may know, is one of the fathers of network science, and then he got for his work several accolades during his career. We thought that nutrition could be that area where we could collaborate, and then that's what I try to do here as well.
And you have developed the International Agro-Food Trade Network with your fellow researchers that helps us better understand the path of global food distribution and to trace food contamination. Is that correct? Can you explain us a bit?
Yes.
This all sounds very, very scientific, so I think everybody would like to know in detail what it entails, the whole.
Yes. Actually, what I saw so far, the best explanation was in the Wired magazine, the online magazine, where I even wrote to them that I've never seen such a beautiful translation of what happens. But I try to summarize it in some sort of everyday layman terms, what happens. So imagine that food, what we eat, if you put a piece of food in your mouth, on average, they take something like 2,000 kilometers, a food molecule, from the plant on the fields or from an animal. That molecule takes 2,000 kilometers in your mouth. That is average. That means that what we eat goes almost around the world. And I can tell you examples when, for example, Scotland, they export to Thailand, they export salmon because it needs some manual work. They wrap it and then they package it and then bring it back to Europe. The same Europe, big buyer of South African products, but they are not that expert in packaging. So they send it from South Africa to Holland, to the Netherlands, where they do the labeling, the packaging, everything according to the EFSA and the European standard, and they send it back to South Africa, and South Africa then export it to Europe. So this is enormous travel all around on this hub. So we wanted to map the network on this travel happens. And this is a very simple database called ComTrade database of the UN, where it is reported what country, what amount of food and what sort of food export, and other countries what they import. From this, we can put together the typical path what foods are taking all around the world. And then there comes the network that in this path, first of all, the path they follow the famous Barabashi model, the scale-free networks, which means that it's not evenly distributed at all. Some countries are much, much more middlemen in this network. Some others, they are just exporting or importing to neighbor countries.
And could you trace agricultural raw materials or processed products as well?
Depends on the data. In this is just import-export. We don't have access to more data. But I was in Dubai once, where the agriculture food minister there, they showed us their program, the Food Watch program in Dubai, and they have the technology now that they really, from raw material, they can follow, and you can check on the barcode that what sort of environment the food went through while it arrives to you. So the big, actually that will lead us very soon to the big data, that now incredible amount of data are available, but we don't use sufficiently. So this is the basis, by the way, of the computational nutrition, what I am doing here in Debrecen.
So you produced a map at the end, and in this map you indicated the hubs.
Yeah.
The most important cities or regions that play a crucial role in this process or in the distribution of food?
I think the best example what I can tell you that imagine two huge harbors, Singapore and Rotterdam. Both has something like close to 200,000 vessels going through the harbor every year. What's the difference between them? That to Singapore, the by the way, if you just think about a vessel or a truck on the road, despite all the technological developments, you have much more chance that that truck or vessel carries food rather than any fashionable mobiles or something like that. So quite exactly, if you randomly stop a truck on the road now, then you have about 70% chance that it carries food. So the food remains the most obvious medium what we are conveying to each other. So imagine Singapore and Rotterdam. The big difference between them, that to Rotterdam, the food arrives via several countries and goes from there to several countries after each other as a sequential process. It is the most important middleman in this process. Singapore is more likely that there arrives a vessel from a country, and that country was the raw material producer. And it goes to another country where the people eat it, and it's over. So the step, what it takes, is 2-3 countries. To Rotterdam, arriving there 5-6 countries, and going from there 5-6 countries. That's the big difference between them. Mm-hmm. And this is what the network describes, that be careful, because if there is a contamination, what happened in 2011, where 5,000 people got very serious E. coli infection in Germany, they couldn't trace it back where it came from for 3 weeks, because it was not immediately from the source. And then when I was at the Imperial College, then my colleague sequenced the E. coli, what they found there. And it turned out that the virulence strain already was present in 2009, 2 years before, in the seed of the sprout, what in the end turned out to be the culprit. So Egypt exported it to Rotterdam, and from there it went all around in Europe, and 2 years later it became an outbreak. But it was very difficult to trace it back because the complexity of the network, especially in Europe. So when I gave the last interview about this, then New Zealand was very worried that how about them? And then they said that you don't need to be worried because you are not the hub of this universe. But the US, especially the US-Canadian border, should be worried. If there is an outbreak there, then it's very difficult to trace back where it came from, because they are also a hub. That's a typical example.
Mm-hmm. And how can we connect big data with your network, with your research on networks?
All this is, the construction of the network is on data. So currently what we are doing with the food composition, this is our research here currently, that the basis of it is the data, where to get the data. Now there are something like 1 million publications a year. That's an enormous number. Even if I take out all which are irrelevant, tens of thousands remains what we don't know what to do with them. So the most important, almost I can say that like lab work for us is interpreting the publications and putting the data into a database which then can be programmed. So this digitalization, which is not digitalization in the sense like image. A database is not an image. A database is structured, what can be programmed, and putting those data which are published into this ontology, into the structure. Also interpreting, some people say that people say like certain food. What is the quantification of liking? This is different again. Surveys or there are machines, what machines can give you an idea that how much you taste that food. So all this can be quantified, putting in a well-structured database, and then now there comes the big data means that pattern recognition, statistics, visualization, all these are pattern recognition. And that is always valid only on a big population. So it's very difficult to say that now we will give you advice for individuals. It's unlikely. We will be able to give advice to funding agencies, where to go into research, or the public health agencies that a whole population can be, on average, be healthy, but individuals will not see the benefit of this for a couple of decades. I would say there's the personalized nutrition, which is decades away. But already you can see that if you, on average, eat less sugar, then what will be the average benefit for the population? Individuals could be very different from the average. It's difficult to say. So big data comes from the existing measurements, existing observation, then to put it together in thousands and millions even data points. By the way, just imagine Facebook. The estimation is every user gives about himself something like 5,000 data points. If I consider a like, email, any reaction is one data point. These 5,000 data points are very useful, of course. Finding out about the population. It's not a spy, the Facebook, on you, but it is spy on a population, on a cohort. And this is what we are also doing, but not spying, but simply giving advice, health advice on big data.
And how do you use big data in the field of nutrition or during your everyday work? What are the most inspiring or interesting ongoing research projects in this field?
Now I got a very interesting request from Nestle. Nestle is for 15 years almost a partner whom I'm consulting. They are using my model, which very flatteringly they call the round the world Baranyi model. So there are several thousands of quotations of the Baranyi model, and this is why they started this collaboration with me. And then currently what was nice from them, that simply they said, could we say that what they produce, infant formula, say in China or South America, which are big markets for them, could we say it would be worth introducing the infant formula different composition for different age of the baby until about 1,000 days. So imagine a baby, the first half a year, that's crucial, but then the next year, and the infant formula would be in these countries introduced in different way. But for that, we need statistically or mathematically prove that, yes, the mother's milk, the breast milk, composition is different from the first week, and then the first half a year, and then the first, say, 2 years. It depends on how long you take all this. And then that research, I find it fascinating because I use my expertise to do it. They want this expertise, and there would be immediate benefit for them and for the population because they would be more healthy. So that application is what I like in my science.
So you mentioned the scientific model named after you. Could you please tell us a bit about that?
Yeah, that's very different. I mentioned it because this was the reason why I got connected by Nestle. But it's a different thing, and that's still until today one of my favorite things. Bacteria, when they arrive in our system, for example, but just in the food, they arrive in the food, they go through environmental change. Now, this environmental change is nothing different from the culture shock, what I went through coming from a communist country to England in 1990. That means that the expression what the microbiologists are using, down-regulate or up-regulate certain genes. That simply means that, imagine a bacterial cell has something like E. coli has 4,500 genes, but only 1/3 is active. The others are not active. That's very similar to our expertise. So I used to speak some Russian, but that expertise was not necessary anymore. Not intentionally. I would love to speak Russian today, but I forgot it. So I down-regulated that expertise, just like the bacteria down-regulate a certain gene. That protein is not there, and another 1,500 combination of genes will be expressed in another environment. Now, during this time, when you go through this, the certain expertise are not necessary, other expertise are necessary. During this time, you and we, this is what we were working on, we can predict, hopefully, the future. So, and that could be, of course, wrong. And that's the same in society. In 1990, there was a big change in Hungary. And that time, we tried to predict where Hungary will go. Actually, it did not happen, but that's a different question. But at that moment, from a certain environment, another environment is formed. And during that time, the upregulating and downregulating certain expertise, we try to predict where it goes. Bacteria are much more reliable, by the way, than human societies in that respect.
So does it mean that your model that was originally for bacteria can be also applied to human society?
Yes, because what happens is, but depends on the data again, that there is with the bacteria a critical substance always, what is the most important for the next environment, a critical enzyme, a critical something, what the bottleneck almost in that process. Now, if we can decide what is this critical process, underlying process, which doesn't show yet in the GDP, for example, doesn't show in the bacterial concentration, but an underlying process. And by the way, a very typical underlying process is the education. This is why the universities and generally the education system is something which doesn't appear immediately on the measurable level of the wealth of a country, but it can be used to predict what will happen. A well-educated population, you can be much more brave to look in the future. Now, that's the same with bacteria, that in the new environment there is a critical enzyme, what they need, and if they are already there potentially with that, then you say that, okay, that will be a good growth environment, and the lack phase, which is a certain delay in the growth, that's the culture shock environment. From that, like in my case, for example, arriving to Britain, my critical bottleneck was not the English language, because I spoke reasonable English by that time. My bottleneck was to get used to the fact that this environment, this society is very much planned, predictable, and they like if somebody is predictable. They like if somebody says, this will I do, and that's definite. Sometimes I say that I trust more an English gentleman word than a Hungarian sealed paper, because the sealed paper for us is a lot of times how to avoid and how to find excuses. There it is, if you promise something, then you are expected that you do it. Why wouldn't do it? You said so. So that thinking affected me a lot, and I changed to this. So before that, I was more unplanned person, a little bit messy person. But I think in England, I became much more organized and planned. And I like planning, and I like reliability now.
Are there any research projects that are based on your scientific model that you just explained to us? Or if there are any, which is the one that you're most proud of?
I think the biggest research project was, and now it's in America, so I started a database, a big database called Combase. You can search it on the internet, and I'm very happy that today, if you say Combase, then that database comes up first, because originally when we started it more than 20 years ago, then a community database in Florida, that was the first in the Google search, but now Combase, my initiative, that's what comes first, and then American, English, British, and Australian partners created that, and they based everything really on my model, how you can predict from those data, and until today they are using my model for that. Now it's totally in American hands, and then I don't participate in Combase anymore. But if you go on that and you want to, say, predict in a new formula, a new development, food development, they want to check that whether what will be the best before or use by date, what should be. Then they go on the Combase website, and then they have a look at the currently available data, which consists of something like 70,000 growth rates, different bacteria, different environment, food environments. And then they use my model, and then they predict that, shelf life will be not significantly more. And then EFSA and a lot of European agencies, they accept it one of the arguments that, that product can go. Also used, like I mentioned, Nestle, but Unilever was a partner in that. So these are ongoing, luckily, that even if I don't participate in that, but still it goes on.
It's based on your studies. It's based on your
Yes, and that's very
knowledge.
nice, and I'm very happy about that. But what I am doing in Debrecen has nothing to do really with the microbes. This is the nutrition, what I am doing currently.
Do you have any international students working with you at the Institute right now? And if you do, would you care to share some tips with our current or prospective students who would like to be part of the UD family so they can prepare better for their experience?
Thanks for the question. Of course, I have enjoyed working with young people because they have the ability of raising their eyebrows. This motto was because I started a seminar in 10 minutes in England, and they began to call it Sem10, and I liked it because it has a certain meaning of szemtelen in Hungarian, which is like cheeky, and I always like the attitude in science. By the way, let me mention Richard Feynman, my role model. He said that science cannot be done without certain irreverence. And I agree, absolutely agree. I encourage my students to don't worry about being cheeky. So this is where Sem10 comes from, because you always need to doubt. And there is no such thing as professor tells you what. The professor is always in the same doubts as you. So we work always together. So going back to the original questions, yes, I do have international students. We continue the seminars. I am very happy that the students went through the first half a year, and then I can see after the first very, very uncertain steps, then now they like it and they want more, and then they ask. And these seminars are exactly in this spirit. The motto is, make me raise my eyebrows. In Hungarian, rácsodálkozni. And that's the most beautiful part of what I am doing when young people raise their eyebrows. I didn't know that. It can be anything in science. And this goes to the next question, the tips. My tip is this ability of raising your eyebrows. And it can be history, it can be politics, everything can be discussed, but also science. And that's the most interesting part, what Feynman said, this irreverence of science. The point is not to have this constant respect to your professor, or no, the professor would like to be taught by you, by the students. So I always say to my students that I suck your brain because I want the feedback, and from that I learn a lot. But you cannot do that if you are worried. So anything can be discussed. And this is what I would like to say if young people come to this UD family, that as long as they have the ability to find the pleasure of finding things out. That's again Feynman. Feynman wrote a book, The Pleasure of Finding Things Out. When he was asked about his Nobel Prize, he said that I have already had the pleasure. I had the pleasure when I find it out. This Nobel Prize is something that, okay, if you want, you give it to me. That's another point. The point is this ability of finding this beautiful. So if the students come, and this is a very good environment to show this enthusiasm, then they will find a way, especially in interdisciplinary sciences. This is why I went to this area, because interdisciplinary science is where I didn't need to do something great in mathematical terms with the so-called Baranyi model. It was routine for a mathematician. It was routine for a microbiologist, but nobody connected the two. So if you want to say I was that one who was the king among the blind because I had one eye, But in fact, what was behind it is more that nobody tried to understand what the question wants to be. That's the most important part, by the way, the good question. And then that's what made it used. And then now I'm happy that people find it useful.
So what we can basically take away from what you've just shared is that students should never stop questioning and exploring, and not to take an answer for granted just because it comes from a professor, because there's always new ways to approach a certain part of science, right?
Yeah. Yeah.
And I think that might apply to everyday life as well. With your experience back in the UK, if you were to stick to your old ways, probably you wouldn't have been able to fit in so well, but you kind of questioned your previous way of thinking and tried to find new ways, right? So probably that's what our students as well can do when they come to Hungary, because obviously coming from a totally different culture might be hard for them, but if they keep their eyes open and they're open to new things, never stop exploring, then good things might come out of that, right?
Yes. For example, 2 students. I have 3 PhD students currently, and 1 Hungarian, 2 foreigners, and the 2 are Brazilian and a Syrian. And I think, I'm sure that when they hear this, then they will agree with me that at the beginning, you students, they don't know, they try to find a way, but how they are getting on their feet, and then they understand that they are partners. They are not somebody who copy or follow the professor. They are partners in research. Just let me tell you that many Nobel Prizes were given to students and professors. So in my area, Jacob and Monod got Nobel Prize with their professors. And then the professor was asked, what was the professor's greatest discovery? And he said, Jacob and Monod. So that's what the spirit, what we would like to see, that we, with the students, we are partners. And then there are many things that I know better. I am happy to pass it on. But please enrich me with your questions, with constant doubt, because that's a feedback to me, where I can myself develop.
We are so happy to hear that students can give such a fresh eye to your research projects or
to your work.
Yes, to your work. And we also encourage our audience to check these very interesting networks and models that we have just discussed. And also take a look at our website, which is edu.unidep.hu, and check which programs are available for our international students, fully taught in English.
Yes, thank you for listening, and tune in next time. Goodbye.
Thank you so much,
and
József.
thank you.
Thank you.
Bye.
So much,
And
József.
thank you.
Thank you.
Bye.
So much,
And
József.